This essay, No Silver Bullet, published in 1916, I say is probably one of the single most important essays ever written about IT. I don't say that lightly, because what I have seen over 40 years is this consistent quest for the silver bullet. You know, you can program 10 times faster now, or this is going to solve all our programming needs. One of the great hypes right now is AI. Programmer is going to become out of date. AI is going to code all our programs. Like, are you nuts? I've been dealing with AI for 40 years. It's not going to code all the programs. But time and again, you will hear this. It's like once a decade, there's some new thing that's going to be the great breakthrough. Back in the start of the 90s, there was object-oriented development. You can program 10 times faster with those development. You don't need to do software engineering. You know, you don't need as much management, or you don't need to do quality assurance. You don't need as much management. It was, and I actually wrote a book refuting all that called Pitfalls of Object-Oriented Development. It's like I love OO. I you know, spent 5 years of pages doing Objective-C coding. You know, working 70, 80 hours a week. I love actually Objective-C still is probably my favorite programming language of all time. But with 5 years of development, I knew what object technology could or could not do. And the whole purpose of the book was to pop the hype. I have a book that I'm in theory working on called Pitfalls of Modern Software Engineering, because a lot of the stuff that I wrote for that book 20 years ago applies to any new technology or methodology. In fact, reading set, I think it's number 7, Webster 7, are basically taking the pitfalls that I wrote on object technology and simply updating them for any particular, you know, for any given technology or methodology, a TOM. So you have, oh, agile programming is going to solve all our problems. You know, oh, functional programming is going to solve our problems. AI is going to solve our coding problems. You know, programmers are becoming obsolete. I can't tell you how many times. There was a commercial program released, I want to say back at the start of the, no, I was already programming. Probably released in the late 70s, called The Last One, meaning the last program you'll ever need to buy. Because in theory, you could type in your specifications here. I missed you on the roll. You are?
Stephen Richards.
Okay. You know, mind you, we're talking late 70s technology. I think it was written in BASIC and ran on microcomputers. But this was supposed to be able to just key it in your specifications, and it would create a program for you. We had what was called 4th generation languages. You know, we won't need programmers anymore because managers can take 4 GLs like Power Builder and write the programs themselves. And these things come and they go. They die. They are forgotten. And Brooks' analysis from '86, from 20 years ago, still 30 years ago, still holds up exactly well. That he talks about essential and essence and accidents. What he's talking about there is essential complexity means things that just can't be avoided. Accidental complexity is complexity that's specific to a given problem. You know, if I'm trying to sort a million numbers, that's got some accidental complexity as a result of what the problem set is. And I can try out different algorithms to sort a million numbers. Essential complexity is stuff that shows up inherently in software engineering. And he talks about 4 specific things. First is the complexity of software increases non-linearly with program size. In other words, what he's saying is, here's size, here's complexity, and we sort of assume, well, you know, as size grows, complexity is going to grow the same. No, it goes like this. Because each new aspect of complexity within a program can act as a multiplier. In other words, it's not additive. It's you know, I've got 10 states here possible, and I've got 10 states over here possible. I don't have 20 states, I have 100. Because I've got these states times these states. And it's why you have, it's why, frankly, quality assurance is so tough. Because you're having a hard time getting your arms around the very massive potential state space of the software system. And you have to design things to try and define. First, you have to design the code to actually delimit boundaries, so you have a massive state space, but it's all within boundaries. And we say, okay, let's try all the boundaries out, because that's a much smaller set. And if we can get that, then we can start making some predictions as to what's happening inside. He also points out that the complexity increases as the size of the development team increases. The more people are involved in a project, the harder it is to manage the project. This is why you have org charts. This is why you get into Brooks' Law of not adding staff to a late project. You get into Conway's Law. The architecture of the completed system reflects the organization of the team that's building it, whether you like it or not. And one of my dictums is that if I'm doing a project, I would rather have a smaller number of really talented software engineers than a large number of really talented software engineers. I really would. Simply to manage the communication lines and the intellectual complexity. Keep it in as few minds as possible. Because the more people are involved in the project, everyone on the project has got their own mental model of what the software is, what it's supposed to be doing, what it does, who's responsible for what. The more people you have without perfect communication, the more it drifts apart. And you have people, you know, we're back to what I was talking about before the break of, you know, you've got 5 people working on stuff and everyone thinks that someone else on the team is handling the 6th aspect. And you don't learn until late in the project that, oh no, no one really ever addressed that. Conformity. I come from an era where I was, you know, writing code that ran, my gosh, some of my earliest projects when I was doing it at Monitor Labs. These were embedded data acquisition systems, so you had maybe 1K of memory and an 8-bit processor. I knew the entire memory map, you know. I had control over everything. Consider the environments you have today when you're programming. Between the operating systems, networking issues you've got to deal with, the language libraries, third-party libraries, other programs you may have to interact with, data formats you may have to deal with. The environment for which you're coding is increasingly complex. And it's just going to continue to be that way. And we get into the issue that I've talked before about that also starts to impose an upper bound on the quality of the overall system because you're now at the mercy of all these third-party systems. It also, and I had this conversation with a friend online, it's also an upper bound on the security of the system. The more I'm dependent upon outside, you know, systems and resources, if they have security holes, those are now my security holes. So I can think, oh, I'm doing a great job, you know, I've got everything well coded and protected and so on, and someone comes right in through the library that I'm using, or the operating system. Changeability. We've talked some about with maintenance, if people, you have this pressure to continually to improve or fix existing systems. And that tends to incur software rot. Because you're doing what's necessary to get that new feature in, and your software tends to become fragile over time. And the last one, visibility. This is one of these, this is, of many ideas, this is one that struck me years ago while I was at a lawyer's office down south somewhere. I thought, this is so great, this is a great insight, and then some months later happened to read Mythical Man-Month and said, oh yeah, Brooks talked about it already. how many of you have seen the MTC, Utah Valley Hospital, the courthouse downtown under construction? Most of you, everyone here has seen buildings under construction, okay? You can look at, I dare say none of us are general contractors. A few of you might have, construction experience, but I bet both of us can look at a building under construction and say, I have a pretty good sense of how far along that building is. Is it just a framework? Do they have Tyvek insulation up? Are they starting to actually put up panels and windows? And you can, without a lot of skill in construction and with a few moments glance, get a marvelous first order approximation for how complete a building is. Guess what? You can't do that with software. It is invisible, and it is invisible in ways that are hard to tell. I can do code inspection, and I can do diagrams, but a diagram is my abstraction of what I think the software is doing. But how do I visualize how the software is actually operating? And where the actual holes are, and what the gap is between what the software is supposed to do and the state of the source code currently. This is one of the most challenging aspects of software metrics, telling how complete a program is. Because it's extremely difficult to take a code snapshot and say, we are at this point and we will have the rest done in 17 days at this level of effort. And you also don't have people trying to move into buildings that are half complete. Software, you have users, program managers saying, well, it's good enough to me. Let's start using it. It's like, no, it's not done yet. He does talk about some things that do help. Buy versus build. This is something I run into all the time in project review and failed project analysis. Again, remember, Fred Brooks came up at a time where back in the 60s he was doing the operating system for the IBM 360 mainframe. So he, over all these decades, has watched this tremendous explosion in software. There's a lot of software you can buy. Rule of thumb, we'll talk about this, I think, in another lecture, but you buy what you need simply to compete, and then you buy what you need simply to play in the game, and then you build what gives you a competitive edge. You don't see a lot of companies, if you go back 30, 40 years, you saw a lot of companies that would build their own accounting systems from scratch. No one does that today. They go out and get QuickBooks or Oracle Financials or SAP or some off-the-shelf system which then gets configured and to a certain extent customized. He talks a lot about requirements refinement, rapid prototyping, incremental development. One quote from him, one quote from John Gall. His quote is, and this really is a key quote. End users don't know what they want until they see it. I wish it were otherwise. I have had at least 2 failed projects where I was acting as an expert witness. Situation where a developer was brought in to either modify or create a replacement system for some old legacy system. And the end user said, we want it to work exactly like the old system, but better. That was the exact phrase that showed up in 2 completely separate cases. And my time at Pages taught me that too. Pages like, we have this great, innovative user interface, drag and drop, design oriented, and people said, we want it to work. We want Emacs key bindings. We actually had people who wanted Emacs key bindings. Mostly they wanted WordPerfect key bindings. So version 1.1 we put in WordPerfect and Emacs key bindings. Because when you're competing, you can do what the customer wants. John Gall, Informatics. Gall was actually a medical doctor, but wrote this little book, and it's hard to find. It's mostly out of print, but remains one of the best analysis of actual system design. And this is a quote I keep coming back to. A large, complex system that works is inevitably found to evolve from a small, this should be simple, not simply, a small, simple system that works. Now that may seem obvious, but what you will find is a big bang approach to software. You know, we're going to do a kitchen sink release of the system, and we're going to release everything at once. And that's a big, big target for a failed project. My colleague Bruce Henderson puts this in a much simpler form and says, start out stupid and work up from there. And it may seem obvious, but I trust you. You're going to find situations where you're going to be in an organization that wants to do a big initial release rather than starting with a small, simple system that works and continuing to enhance and refine it and keeping it working all the time. Great designers, and this gets back to this is one of a number of talents in software engineering. Those who can design and architect systems come up with the concepts, the abstractions for the system that are elegant. That should be cleaner, not cleaners. Best designers produce structures that are faster, smaller, simpler, cleaner, and produced with less effort. A good architecture has solid bones and lends itself well to enhancement and expansion. Complex or fragile architecture will break when you try to upgrade or enhance it. Any thoughts on what we've talked about so far? Observations from your own experience? Yes?
I'm working on a system right now where when the company first started out, there were a bunch of master's students working there. And someone decided to build their own ORM.
Mm-hmm.
And it's just
ORM?
It's just like a way to manage your database.
Okay.
And like it builds your connection and everything to it and handles all that. But there were a ton of bugs, there were connection leaks, and now it's just this big massive, it's called ginormous. And it's like this ginormous blob in the middle of this system that they're trying to migrate off of it. It's a huge process. So that buy versus build for there, because there's tons of open source solutions for that.
Yeah, you really do want, I mean, and this, you're going to find this more and more. You want to find open source, whatever, for anything that is simply what you need to play in the game, as I said. And then leap off from there, because otherwise you're going to waste a lot of time and cycles reinventing the wheel. Yes?
So, on the topic of buy versus build, this is actually something which has come up in the company that I'm in, and it's not my project, so I don't know very much about it, but it intrigued me nonetheless, where a number of years back they bought a solution to a product, and then the people who developed it for them changed management, had some structural rechanges, and are now hiking the price up beyond belief. And so, you know, they want to get, they want to get
off of it, yeah.
Yeah, they want to get off it because they can't afford
Yep.
it. And so, I mean, they want to build their own. And which, I mean, is its own problem because now they're having to rebuild a system which already worked and try to make it fit into the spot.
Make it backward compatible, yeah.
Which is a...
Yeah, and that is a very real problem, and this is part of the temptation. If you buy, you're typically licensing. The advantage is you get all the feature upgrades, you get the bug fixes. Disadvantage, you're often paying a yearly license fee depending on the type of software. It's been a lot of the impetus behind the open source and related movements, with the idea of I can get the open source software, and you know there are people who are trying to enhance it, but no one's going to jack up the licensing fee on me. But the problem you have there is that often a lot of the open source software is sort of 80% complete, and because it takes strong financial incentive to get that last 20% really nailed down. Other thoughts, observations, anyone? Okay. Chapter 17, he basically talks about all the people who took exception to his no silver bullet. What's most interesting is that this chapter was written in 96, and he quotes a number of people who all feel they have solutions to the silver bullet issue, and those are all things which you've never heard of because they all died a quiet death many years ago. Brad Cox, inventor of Objective-C, had this software factory idea, the idea that you have these interchangeable software components. It really kicked off a whole decade devoted to software reuse, and the discovery of software reuse is that software reuse, by and large, just doesn't work terribly well. Here's this core issue with software reuse. Oh, my detective daughter, she'll just have to wait. Seriously, I have a daughter who's a detective on for the Salt Lake County Sheriff's Department. She and I swap stories. Anyway, let's talk about reuse. Here is a conundrum. Software reuse was a big thing in the 90s. One of the things I got sucked into at Fannie Mae was they wanted to make standard software objects for all their systems. And Fannie Mae does mortgages, so the first thing they wanted to do was a loan object. And I was sort of an advisor to them, or a mentor, or whatever. Well, they got this loan object, and they got to a point where they had like 150 data fields and several hundred methods attached to it. And the simple truth is that the loan abstraction was different for different applications. Even though we think of a loan, well, this is sort of the fundamental business. Fannie Mae buys up mortgages, manages them, sells them as mortgage-backed securities, gets money to buy up more mortgages, so on and so forth. You'd think this was sort of a standard thing, and yet what a loan meant to these different systems was quite different. So Brad Cox thought we were going to have software Legos that we were going to plug together, and we could build software out of that. How many built programs from software Legos? Okay. We use libraries. We use utilities. But he saw this as interchangeable. David, I don't know if it's Harrell or Harrell, had this, what he felt was in terms of software development process, what he called the vanilla framework, which he thought was going to solve all the problems. How many of you have heard of the vanilla framework? Okay, no. I actually had never heard of it until I went back and reread Brooks for winter semester. And I did some searching online, and he's published a few things, but no, it hasn't solved it. Object-oriented development was seen as a silver bullet. And I wrote a whole book basically saying, no, it's not. I agree with Brooks saying there is no silver bullet, and we will not see a silver bullet. Software is effectively hard, and it's why every time you see articles, because like I said, they'll come out every 5 to 10 years, we're just not going to need as many programmers in the future. It's like, oh, no. We need more programmers, and we need more good programmers is what we really need. It's hard work. The essential complexity of building a working software system is really difficult. Any thoughts, observations, comments, pushback? You're welcome to disagree with me. I like a good debate. Okay. Got a little more time there. Chapter 18. Hey, this is a great chapter to use on midterm. All chapter is, it's basically all his basic ideas from his original Mythical Man-Month in outline form. It's like, oh, hey, yeah, there it is. This is chapter 2. He says this. Let's go find the original quote. So, it's a good chapter to learn with. Okay, and then he does his own post-assessment of the Mythical Man-Month. I'm going to, and pardon me for quoting myself again, but I really want to focus on why I said what I said. I said that Mythical Man-Month could be regarded as the Bible of information technology because it is universally known, occasionally quoted, often quoted, occasionally read, and rarely heeded. Try this as an experiment, particularly those of you who currently work in organizations. Go around and ask people, have you ever heard of the Mythical Man-Month by Fred Brooks? Oh yeah, yeah. Yeah, she says it's a really good book. Do you know anything that comes out of it? And I'll say, oh yeah, you shouldn't add people to a late project. Or you can't create a baby in 1 month with 9 women. It's like, do you know anything else from the book? No. Have you read the book? Well, no. Once you get to that point, the rarely heated is sort of the, at that point you sort of assess the organization and say, what's my organization doing and what does Mythical Man-Month say they should be doing or should not be doing? This is so true. The book is well known and almost no one reads it, and even fewer follow it. And yet, having reviewed 150 plus failed IT projects, I can tell you that this is stuff that Brooks lays out is at the heart of most failed IT projects. We lose tens of billions of dollars a year worldwide in failed IT projects. Tens of billions. And most of it could be avoided if people actually read this stuff. This is why you're in this class, is because you're going to go out there and you're going to say, oh my gosh, I see what's happening. And you either will have an opportunity to help redirect things or you'll start looking for a lifeboat. Brooks sees essential arguments about not being about scheduling or staffing, but about conceptual integrity and the need for a chief architect. That really is an important aspect, and it's not, Brooks recognizes that there are some uncomfortable issues there in terms of, well, who gets to be the chief architect and who doesn't, and what you'll find in a lot of organizations is that this becomes the most coveted title, and some organizations you'll have a dozen different architects, which usually means you have no architect. The second system effect, he says, really is less of an issue because of iterative development. But he did talk about the need to define, and this is a good slide to think about when you're doing a requirements document. Define your set of users in your requirements document. Who they are, what they need, what they think they need. These are often two very different things. And what they want, which is often a third thing. Brooks says that he thinks that the Windows icon menu pointer interface will be replaced by voice. I am less certain of that. That's an area where I think I disagree with Brooks. Just as I think, however they may be buried, command line interfaces will never completely go away. Because there are things you can do with command line interfaces you just can't do with a windowing interface. And there's things you can do with a windowing interface you just can't do with voice. Build one to throw away, which he says that's, he's in favor of iterative development, but frankly, he says waterfall method is wrong, but the truth is, even the original waterfall method was somewhat iterative, and it really is iterative nowadays. The third point there, Barry Boehm has done a lot of work on software estimation, and how projects come in, how well they match their schedule and their estimate, and so on. And he refers to Boehm, and Boehm has done a lot of empirical studies. Actually, lots of projects, lots of data gathered. Hardly any projects succeed in less than 3/4 of the calculated optimal schedule, regardless of the number of people apply. This is, in essence, is supporting Brooks' law or the Mythical Man-Month issue. But it gets back to something we've already talked about, which is there is a certain incompressibility in software projects that managers often don't or won't admit. And as Brooks pointed out in his own book, a lot of that is in testing. Of all the things that are most underestimated in software projects, it's the amount of testing required. That's for a couple reasons. One of which is, the most important of which is simply testing is where you find out all the things that you forgot to actually build in the first place. Brooks' law, he notes, there are cases where you can help a project by adding people, often to replace existing people as opposed to simply adding them. But he still stands by it. People are everything, which is what we've been talking about. And it's interesting that he starts talking about some 4G languages. In this case, HyperCard, which is a Big Apple deck thing, which again was sort of going to let average end users program, and HyperCard sort of came and went. Okay, we actually have one more lecture which we're going to do, and we'll get through that lecture. We'll take a break, and then the rest of the time will be for team meeting. But I thought this was going to be the last lecture. I'm wrong. By midnight on Saturday, create your team requirements document and put in your 7 billable hours. By start of next class period, part 1 of Peopleware. It's chapters 1 through 6. Again, Peopleware, large print, very breezy style, big margins. It's a fast read. Webster under number 2 online, and actually let me just go see what that is. And for those of you who actually read Webster number 1, I think you saw these are all pretty short pieces.